dear fellow Toastmasters, dear guests. Today I want to tell you about self-replicating machines or self-replicators. Self-replicating machine is a robot which is able to create an entire copy of itself. We know a lot of things which can self-replicate. These are animals, plants, bacteria, viruses, and so on. But have you ever heard about non-living mechanical creatures which can produce a copy of themselves? Definitely not. But they may appear tomorrow. History of... Oh no. Yes. Don't help. History of self-replicating machines started in the middle of 20th century, when mathematician John Newman proposed the first abstract model. According to Newman, self-replicating machine is a robot which is able to do at least the following. First, obtain raw materials from the environment. Second, produce new parts from these materials. The third, assemble a new member from these parts and program. Currently, there is no any fully self-replicating machine exists yet, but there are several partially self-replicating robots. Some of them you can even buy for your own experiments. One of them is RepRap. RepRap can reproduce all his plastic parts using 3D printing technology. So, generally speaking, you can buy one robot and create a copy to present to your friend. Except purely scientific curiosity, the main goals to create self-replicating machines are: first, for example, some African country can't afford to buy really expensive high-tech robots for its factory. It buys only one robot, which begin to multiply themselves until you get as much robots as you want. The second idea is to inhabit deserts. Robots can extract minerals from the sand to produce their copies. Additionally, there are a lot of sunlight in the deserts, which can be used to charge robot batteries. Later, we can use them to search for oil, gas, or water. The next idea is to let them float freely in the ocean. Robots can extract minerals dissolved in the water to produce their copies, and later we can use them to clean garbage from the water or spilled oil, or do some scientific research. In 1980s, NASA, inspired by this idea, decided to use self-replicating robots to build a base on the moon. Idea is very tempting. You don't need to send a lot of spaceships with equipment, materials, machines, and so on. You don't need to supply food and air and drink for builders. You just send several robots which gather local minerals and until they are able to construct a base for human. The next interesting idea is that we can program a possibility for random error during replicating process, thus creating the conditions for evolution. Robots with beneficial mutations will survive and transfer its scheme to the next generations. Robots with bad mutations will not work, have malfunctions, and probably will not be able to replicate, thus providing natural selection. Speaking about self-replicating robots, we can't but touch the danger of uncontrolled growth. The possibility is very low, but if it happens, the consequences may be disastrous. Let's imagine one nanorobot which swims in the bottle with chemicals. Let's assume it takes 15 minutes for it to self-replicate. In 15 minutes there will be 2 of them, then 4, then 16, then 256, and so on exponentially. By the end of 10 hours, there will be 58 millions of them. By the end of 2 days, they would outweigh the Earth. In the next 2 days, 4 hours, they would exceed the mass of the Sun and all the planets combined, if the bottle of chemicals hadn't run dry long before. That was only thought experiments, but robotic nanobacteria can outcompete real bacteria and replicate swiftly, can destroy the biosphere to dust in a matter of 2 days. That is why some sort of precautions have already been made. Forsyth Institute in California published a special guideline for researchers about how to prevent mechanical replicators from getting out of control. So, dear ladies and gentlemen, if you are going to create self-replicating machines, be careful. Otherwise, one morning you may wake up surrounded with crowds of your yesterday's invention.